Okay, welcome to another video over geometry. This is section 4. This is isosceles triangles. Isosceles triangles, one of my favorite triangles. Not my ultimate favorite, but they're up there. Okay, and what we want to do is we want to complete the steps to prove the isosceles triangle theorem and its converse. We want to identify characteristics of an isosceles triangle, and we want to be able to solve for unknown measures of an isosceles triangle. So what we know about isosceles triangles is that they have at least two sides that are congruent, and an isosceles has two base angles and one vertex angle. Now what I know, given that this is a isosceles triangle, okay, is that I have two sides that are congruent. So I have two congruent sides, okay, and then I have two base angles that are congruent. Okay, and so that's what tells me whether I have an isosceles triangle. If I know that these two angles, which we call the base angles, okay, if those are congruent, then I know it's an isosceles triangle. Okay, and then we also have this other angle up here called the vertex angle. Okay, so if you see a triangle like this, if you see that you have two congruent sides, you can then conclude that the base angles are congruent. And conversely, if you have two base angles that are congruent, you can conclude that those two sides are also congruent. Okay, so if we want to talk about, what I just said earlier about, properties of an isosceles triangle, we have a theorem about isosceles triangles. So it says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. That is, the base angles of an isosceles triangle are congruent. So here's what I'm going to say. So if two sides are congruent, okay, then the base angles are congruent, okay? And then the converse to that is that if you have base angles that are congruent, then the sides are congruent. Okay, so if two base angles are congruent, then the two sides are congruent. Okay, so that's all it's saying. All right, so we can apply this idea. All right. And if we look at this next example, it says, what are the measures of the base angles and the vertex angle of this isosceles triangle? So angle A, and let's just say this, that angle A and angle C are base angles, okay? And then angle B is the vertex angle. Okay, so what I know is that, this is an isosceles triangle, okay? Segment BC is congruent to segment AB. So I know that AB is congruent to segment BC, okay? Therefore, okay, that allows me to then conclude that the base angles, angle A is congruent to angle C, all right? And that's what I know. So because angle A and angle C are congruent, okay, then what I can do is I can solve for x, okay, and so I'm going to do that. So I know that if A and C are congruent, I can just set 4x plus 9 equal to 8x minus 15, okay, and I can solve for x, so I'm going to subtract 4x from both sides, all right, and that's going to give me that 9 is equal to 4x minus 15. Then I'm going to add 15 to both sides. Okay, so then I get 9 plus 15 is going to give me 24 is equal to 4x. Divide by 4. And divide by 4. And so then I get that x is equal to 6. So I've solved for x. But what I need to do is I need to find what angle A is. Okay. And I know that angle A has the value of 4x plus 9. So 4x plus 9. And I want to plug in 6 in for x. So I'm going to plug in 6 in for x. So I've got 4 times 6 and then plus 9. So that's going to give me 24 plus 9, which is going to give me 33. Okay, so angle A is equal to 33 degrees. Okay, and then because I know that angle A and angle C are congruent, then I also know that angle C is also 33 degrees. Now you can plug it in, into this and do, 6 times 8 and then subtract 15. That'll still give you 33. Okay, so I know what angle A and angle C is, but I do need to find what angle B is. All right. Now I know that if I take angle A, add angle B, and add angle C, that I'll get 180 degrees. Okay, so I know that angle A is 33 degrees. I'm going to plug that in for angle A, plus angle B, and then angle C is also 33 degrees. And if I add all those together, I'm going to get 180 degrees. All right, now 33 and 33, if I add those together, angle B, that's going to give me 66. Okay, 33 and 33 give me 66, and that's equal to 180. Now if I subtract by 66 on both sides, then I get that angle B is equal to 114 degrees. Okay, and that's what I'm looking for. And guys, the reality is that you're going to have to show some work on this. This isn't something that you can just do, off of a whim and all that. So let's take a look at the next question and next theorem. And this says that the vertex angle of an isosceles triangle theorem. So it says the vertex angle of an isosceles triangle theorem, the bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. So if you have an isosceles triangle here and here, okay, and then we can conclude that these angles are congruent, okay, then if you bisect, so basically this says if you bisect the vertex angle, okay, and this is the vertex angle, okay, then the base is also bisected. The base is bisected as well, okay, and you get a 90-degree angle, okay, so that's just how one of the cool things about an isosceles triangle, okay, and then we also have what's called equilateral and equiangular triangles, okay, so an equilateral triangle is a special case of an isosceles triangle, and that's something I actually didn't know. Thought they were all just unique, but I didn't know it was a special case, okay. And so if we know that if an isosceles, if a triangle is equilateral, and when I say equilateral, that means that all sides and all angles are congruent, okay? So if I know that if I see a triangle and I see that all of my sides are congruent, then I can automatically come in here and assume that all of my angles are congruent. And all angles, okay, all angles are 60 degrees, okay? And that's just something we got to know, all right? And then we have the converse. So if we know that if a triangle is equiangular, if we know that all of these angles are congruent, then we can say that all of the sides are congruent, okay? So that one's pretty easy. That one's not too bad, all right? But let's talk about this. And it says applying the isosceles triangle theorem and its converse, find the value of n and the lengths of the legs. Okay, so and the legs are the congruent. So the lengths of the legs. So the legs, these are the congruent sides of an isosceles triangle. Okay, so what I see here is that I have this triangle XYZ. Okay. And so what I notice is that angle Y is congruent to angle Z. Now it doesn't tell us that angle X is congruent to either of those, so we don't know anything. However, because these two angles are congruent, all right, I can then conclude that XY is congruent to XZ, all right? And that's because it's an isosceles triangle. So then what I can do is I can set up an equation and solve for n. So I'm going to set up 9n plus 12 and set that equal to 15n minus 6, okay? And I'm going to subtract 9n from both sides, okay? And so that's going to give me 12 is equal to, what is that, 6n minus 6, okay? And then I'm going to add 6 to both sides. So then I get that 18 is equal to 6n. Divide by 6, divide by 6, and so I get that n is equal to 3, all right? So I found what n is, but I still need to figure out what xy is, okay? And so xy, all right, has the value of 9n plus 12, okay? If I plug in 3 for n, I'm going to get 9 times 3, and then plus 12, so that's going to give me, what is that, 27 plus 12? And so 27... 12. 27 plus 10 is 37 plus 2 is 39. Okay, so xy has a length of 39. Okay, and then if I know that's the case, then I can just assume that xz, because they're congruent, is also 39. Okay, now I can't find what this measure is. Okay, I can't find what zy is unless we knew the perimeter, which is the whole distance around, but that's all I know. So I can't really do anything from that. Okay, so on this page, let's just talk about a couple things here real quick. And what I know, okay, we're applying the vertex angle of an isosceles triangle theorem. And so if I know that BD is the angle bisector of ADC, okay, then if I know that that's the angle bisector, I know that this is going to create a right angle and that these two segments are congruent. Okay, I also know that angle C and angle A are also congruent. Okay, now it says the measure of angle ABD, okay, which is this angle here, okay, ABD, which I know that to be 90 degrees, okay, as well, is 32x minus 6, and we want to find the value of x. So what I want to do is I'm going to set up an equation, and I'm going to call this 32x minus 6 degrees, okay? Now what I know is that this angle is a 90-degree angle. So I'm going to set 32x minus 6 equal to 90, okay? And then I'm going to add 6 to both sides. So then I get 32x is equal to 96. And if I divide by 32 and divide by 32, then I get that x is equal to 3, okay? Isn't that nice, okay? So then it says if AB is 21, okay, on this one, this part here, if AB is 21 and CB is 2y minus 3, what is the value of y? So if this is 21, okay, and this is 2y minus 3, now I've already gone in and said that these two were congruent because when I know that we have an angle bisector in an isosceles triangle, it's going to cut these two segments in half and create a 90-degree angle. It's going to be an angle or a perpendicular bisector. So if I wanted to solve for y, I would just set 21 equal to 2y minus 3. Okay, and then I'm going to add 3 to both sides, add 3. So then I get that 24 is equal to 2y, okay? And then I'm going to divide by 2, and so then I get that y is equal to 12, and that's it, okay? So, you know, guys, when you're given information, you have to draw pictures and you have to draw conclusions. You have to go, okay, what do I know? If I'm given this information, what conclusions can I draw from this, okay? Now, on the next one, it says that, now I have an equilateral triangle, okay? I know that all of these sides are congruent. So if all of these sides are congruent, then I also know that all of these angles are congruent. And if they're all congruent, I know that they're all going to be 60 degrees, okay? So that's what I can conclude. I know that based off of facts, okay? So now I've got that angle BAC is 5x minus 20. So I'm going to come in here and say that this is 5x minus 20. And it wants us to figure out what's the value of x. Well, because that's 5x minus 20 and that angle is 60 degrees, let's set that equal to 60. So I've got 5x minus 20 is equal to 60, okay? And if I add 20 to both sides, then I'm going to get that 5x is equal to 80. Okay, and if I divide by 5 and divide by 5, I think x is going to be 14. Or no, x is going to be 16. Let me double check that. 80 divided by 5 is 16. So that's it. That's what I've got. X is 16, and that's all I need to do. So, you know, guys, it's all about understanding what these things are and you know, what conclusions you can draw from that. If you're given a picture, okay, what else can you conclude? What else do you know about that? So, hope you enjoyed this video. I had a blast. I had so much fun, it's not even funny. Maybe a little.